So if you weren't able to make that, I definitely suggest that you go on to the FCE website, and the recording is posted there. I know it's under the data section on the website. And then we're also going to be recording, you probably saw it popped up, we're recording this presentation today. So if you have friends or colleagues that you know might be interested in this but weren't able to attend, they can go onto our website in the future and they can access the link. And so I just want to thank everyone for attending. This is our second workshop for the science workshop series. We also have another workshop coming up next week that's going to be on grant writing. And there's going to be a couple other workshops building on this GitHub workshop that James is providing today. So I highly suggest that you so much. And so today we have the awesome James Sturges, who is the vice president of the FCE LTPR student group. He is an aficionado, I think, in GitHub. He gave a really great presentation last year, giving an introduction into GitHub, and so he's going to be giving a similar presentation today. And so I'm also learning right alongside y'all, so I'm super excited to be able to set up my own site. And James is a third-year PhD student in Jen Repage's lab, and he does some really cool research. So definitely talk to him some other time about his work. But without further ado, I will turn it over to James to take it over.
All right, thank you so much, Paige. Paige might think I'm a decent GitHub person, but I'm actually going to start my entire presentation with a little disclaimer. I'm not a data scientist. I have no formal training in computer science, so everything that I'm teaching you today, just like coding, there are several ways that you can do this and integrate version control into your workflow. I'm not saying that my way is the best way, but I am going to share ways that I found work well for science and kind of an academic setting. I'm also going to provide some extra resources at the end, and again, hopefully put you on the right path to people that are far better at this kind of material than me. But that being said, let's get into it and really go over some of our learning objectives for today and kind of what you should expect to take away from this workshop. So first and foremost, we're going to develop a working knowledge of what Git is as a version control software and like what we're talking about. Then you're going to develop the skills to be able to push, pull, and clone GitHub repositories. And don't worry if you don't know what those terms mean right now. That's all part of the course. We're also going to talk about establishing a file structure that will optimize your workflow and kind of improve how you manage your own data and then how you work as a group. We're going to talk a little bit about handling branch errors and then how to troubleshoot when necessary. And then we're also going to hopefully kind of take away some broader impacts and be able to improve your lab collaboration and data management skills. And then also hopefully have more people that are able to contribute to the FC's data organization kind of at the institutional level. So all of that being said, you've heard me kind of use this term Git and GitHub. What exactly is the difference and what exactly do you have to know about them? So first and foremost, Git is a version control software. So it is a application that runs software within your computer to manage version control. GitHub is more of a hosting server. It's a repository hosting server. So the way I like to explain this to people is that I think of them as track changes and a Google Drive. So instead of your code, each one of those scripts is like a Word document. Git will track the changes that you make in that code or as like a Word document. But then GitHub itself is just the online server where your script and your repository projects live. So hopefully that automatically kind of explains why GitHub would be useful right off the bat. So one of the first and foremost reasons is that that version control software provides a record of previous code. I don't know how many people have at some point said, oh, my code was working and now it's not, right? Wouldn't it be great if you had saved it at a point and been able to say, okay, I need to go back to before I mess this all up, and we're just going to start back over where it used to be. So having that version control, having a record of changes that you've made is really useful for any kind of project, even just for yourself. But then you can do even more with GitHub. So part of it is that it can help streamline collaboration. So at least in my lab, we have a bunch of postdocs that are really helpful, really great coders, very smart people, but a lot of them are often remote. So this is one way that you can help share not only the code that you're working on, but the data associated with it so that it is just easier to integrate and collaborate with other people that may not be in the same room as you. Another huge and helpful important aspect of GitHub and using version control software is that you'll have clear documentation of any changes that you've made to your data or your analyses themselves. And many journals are starting to actually require this. So depending on where you're publishing or depending on what type of data you're publishing, journals may require that you have this publicly available repository that not only shows where the data came from, but how you took it from point A to point B for your manuscript. And then the last 2 points here I want to make is that GitHub is really useful for reproducibility. So not only for your own work, if you wanted to do the exact same analysis the second time around, but it's also really helpful for finding other resources and other people that have already made code for you, and then you can reproduce maybe their figures or using their style with your own data. And then lastly, that kind of ties in with the visibility and the public availability of your data. One thing that is emphasized more and more in science these days is just having everything be publicly available and publicly like transparent about what you're doing with the data. Okay, so I've thrown a lot of terminology at you. I want to kind of take a step back and kind of show you how version control works and really make sure we're all on the same page with some of these terminology. So again, the way that I'm kind of using this analogy is thinking about this like Google Drive. So in this diagram that you see here, you have something like a main server repository, and you can think of that as like a Google Drive, or in this case, it'd be GitHub, where your project repositories are living. Now, if that main server, that repository is public, you can basically copy it to multiple machines. And that's one of the big advantages of GitHub. Let's say you work from home at a desktop, but then you come into your office and you have a different laptop or different computer that you use here. What you can do is you kind of treat those files as if they live on the main server, but then you create a branch or a copy of that file to your local machine that you're using for the day. And then so you can edit it, change any of the scripts or change any of the files that are in there. And then what you do is called push, or you commit those changes and you push them to the main server. So in this diagram, let's look at the like blue side. If I was going to pull from the main server, that just means that that's that copying action where I'm copying the files from the main server to my local machine. If I make any edits, I first have to commit them, which is just kind of like prepping them before they go to the main server. And then if I send the push, that's when it will actually change the main server. And then any other computers like the green or the orange machines over there, those would then see those changes that you've made if they try to pull the main file. Okay, everyone good so far? Cool. And so one of the things that I like to do and what I'll be showing for most of the workshop today is an app called GitHub Desktop. So this is an optional GUI. It's not something that you need. Many people like to have GitHub and Git directly integrated into their RStudio. Totally another option, totally doable. I like GitHub Desktop just because it's a little bit more like a user-friendly image, a little bit easier to work with. And there's a couple of things that you can see. So in the top left corner, it shows you which repository you're working in. And then underneath it, it shows a list of all the changes that you've made to that script or to that project repository. So in this case, I've made 60 changes in this example, and I've highlighted one of them that's showing changes in the script, like the R script itself. And I like this just application because you can see it highlights parts of the script that were removed in red, and then it highlights stuff that was added in green. So you can just kind of quickly see what's been changed at that level. You can also see up here, I put this example in here just to show you. GitHub Desktop says pull origin, and it's hard to see, but there's a number 3 right there. So those are new commits that other people have made, and they have pushed them to the main repository on GitHub, but I am behind. So I have made changes, but I have to pull those new changes that other people have made. So just wanted to show you that it can easily be seen in GitHub Desktop. And one other thing that I really like about GitHub Desktop is that it's pretty easy for figure comparisons. So let's say you're messing around with like the shape figure or the shape of a figure. You can kind of see the before and after. And I just have an example of that right here with an NMDS plot. So it's a good way to see that. Okay, well, let's talk a little bit about GitHub structure and some of the features of it, and more tailored to a scientific or lab setting. Okay, so everyone today will either have already made their own GitHub account or has their own GitHub account already. So that is your personal account. But what I would also recommend is that most lab groups have their own organization level GitHub. And so on the right, I took a screenshot of just like my public profile on GitHub. But then if you see down at the bottom, I've put a gold star down by the organizations tab. So those are also GitHub organizations, like a server, but those organizations have different levels of security and different levels of access. So we're going to talk about that. In our lab, it's pretty much everyone gets kind of equal footing. So there are people that kind of manage the lab. Ryan James is kind of the head postdoc in our lab, kind of managing the system. But for the most part, all of our repositories, whether you're the PI, a PhD student, or another person, as long as you're within the organization, you can push and pull from any of our repositories. But we'll talk about security in just a second. You can set within organizations different roles and different criteria for who can and can't edit, essentially. And the way that you can do that is by essentially creating a hierarchy. So one thing that might happen, let's say someone creates a branch on their computer. They have created a copy of some script, some repository that they're working in. And then they make some edits. But then they want to change those and merge those back into the main repository. What you can do and what I would recommend, especially for anything that's like sensitive that you have a bunch of people working on, you can set basically restrictions so that certain people have the ability to edit or not. And then if they make edits, sometimes those edits have to be approved. So in this diagram, you have the potential like red-haired woman. She has to approve the edits that have been made before it gets merged into the main branch. And so this kind of got cut off a little bit, but this is an example of one of our project repositories that we work in. I'm in the collaborator tab, and don't worry, we're going to go look at GitHub in a second itself. But under the collaborator tab, you can see which students and which collaborators have access and then what their role is. Oops. So that's a good way to manage your files as a lab organization. And if you're worried about security, even amongst your own team, you can decide who has access and who doesn't. Okay. And where you do all of those features is in a section under the settings called the danger zone. They make it very, very difficult to accidentally do something bad. Like it is very, very hard to delete a repository accidentally. You're not going to be able to do that unless you seriously want to. But there's a few other things that you can do to these repositories. You can change their visibility. So on GitHub, your project folders or your repositories will either be public or private. If they are private on your account, you're the only person that can see them. If they're private within an organization, like your lab has a GitHub, only members of the organization can see them, but every like member of the organization will see the repositories. And then if they're public, anyone can access them. Anyone can look at them. There are branch protection rules. There's ownership. Whoops, I keep doing that. There's you can archive repositories and you can delete repositories. So all of that happens in the danger zone in settings, and we'll take a look at that later. Another really key aspect of GitHub is what are called README files. And you can think of these as kind of like the cover page or like the abstract, kind of the short and quick thing that someone might look at when they click on one of your repositories. So there's one thing we'll look at today is how to make a special README file for your own profile. And essentially the only thing you do is you make a repository that has the same name as your GitHub handle. And that becomes the README for your like actual profile. You can also do READMEs for each individual repository that you made. And here I just took a couple of screenshots of part of our README because it's actually quite extensive, just to highlight some of the different things you can do with it. So this is a project that I'm working on with a bunch of different LTR collaborators, and we wanted to have our emails embedded as hyperlinks. So we have our all of our contact information there. We also wanted to do like a project summary and have a conceptual diagram. So we embedded figures into that. And then we also had some like key definitions that we wanted figures for. So you can embed figures, hyperlinks, text. You can do bullets. You can do numbers. It's very much like standard text editing for a website. But I wanted to show you some of the possibilities with those READMEs, and we'll practice making a little README for your profile later. Okay. No, I've been talking a lot. Real quick, before I jump into another section, is there any questions up until this point? Anyone on Zoom or anyone in person? Any of the terminology? Cool. All right. I want to get through the PowerPoint, go through it, because I think most people will learn this a lot better just by doing it once than by hearing a lecture. But I want to give you a few more key definitions and kind of show you some examples. So one of the things that we're going to practice right off the bat is called cloning a repository. And you can think of this exactly like it sounds, as creating an exact copy of this repository that would live on your machine. So like I said before, any public repository can be cloned, but just because a repository is public does not mean that you will have access to change someone else's public repository. You'll be able to access it, download it essentially, but you won't be able to like push and change it for them. So the way that that happens, we'll take a look at GitHub in just a second, but under like any repository, you'll see this green button that says code in the kind of right-hand side. And then you'll see options to either download the zip file completely or open it with GitHub Desktop. Both are totally fine options. So it depends on what your intended purpose is for cloning. So if you're cloning with the intention like, oh, I'm now going to become a collaborator and I'm going to start working in this repository, obviously you're going to clone the whole folder and bring it into like your GitHub desktop app or wherever you're storing project folders. If you found a resource online that you said, oh, wow, I really liked how they made that plot, I just want to download their script. Maybe you just want to download that repository as an object or like files in your computer and you don't want it in your GitHub desktop. Both are totally fine, but this is where you would go to clone those files from a public repository. Okay. Again, GitHub desktop app is a GUI that helps you manage it. And then it can also be directly integrated into R or R Studio. So moving forward, I'm going to show the version of GitHub desktop app. If we have time, maybe we'll look at some of those resources for integrating it directly into R or R Studio. One other thing that I would recommend is creating a folder on your desktop or again, wherever you're storing projects. And I personally like to put all of my repositories into one GitHub folder. So I know that everything that is talking with the GitHub server is stored within that folder. Some people don't like that. Some people already have a project folder. They would rather have the writing and the code all together. Maybe people like to have multiple folders for every project. However you want to do it. I'm telling you that I like to have a folder with all my repositories just in one place. The other thing that I would heavily recommend that you do as a lab, and especially anyone who's going to be coding with more people remotely, you want to make sure that you establish a file organization structure. Again, there's a million different ways to do this. This is just two examples. And I think these kind of have logical arguments for science. So the first and foremost thing that I do is that every project in my GitHub folder has a project name, whatever that project is. Directly inside that folder, there's a couple of key folders that I always have. So I'll have a data folder, and now I've started doing a figures folder and a tables folder because those are almost always going to be the outputs that I generate from code. I'm either generating figures or generating like an Excel file that's going to be turned into a table later. Some people like to have a folder for scripts. That works out very well. So you can call it R, you could call it script, you could call it analysis, whatever you want to call it. That's one way to do it. If you have data that's being harmonized or being assembled from like a raw data set somewhere, and then you're filtering it out, it might be worthwhile within your data folder to have two options. One where you have the raw data, and that should be directly from wherever you got it as a source. And then maybe some processing where you have a refined data set that shows what you actually used for the paper or something. Bunch of different ways you can do it. I would talk as a lab group, establish that, and try and make it consistent between your projects. We can look at some of the projects that I'm working in right now. But again, having something that's consistent will make it easier for you to make code reusable, but it also makes sure that organizationally, people that come into your lab and come into like your GitHub organization, they will be able to pick it up quicker and be able to integrate that skill across projects. And then one more thing that I'm sure Gabe has talked on many, many times and has still been promoting is our projects. So this is a very useful thing, and I don't know if you saw in the last diagram that R project, and the same way that I do it in one of my examples, the R project just lives at the highest organization of your folder, and that makes it so you never have to set your working directory. R knows that if you open that project, you are working within that folder, and so that makes your code more producible. The other thing that I really like about it is that you can open two R projects at the same time and run two different sessions of R simultaneously. So in case you're like updating a script or modifying it from a previous version, you might be able to run both versions simultaneously to figure out what's going wrong or something. And then if you need help or want more information about R projects, it's not what we're doing today, but I put a link to the POSIT support on that topic. Okay, was a very long-winded introduction to kind of give you guys a overview of the many different aspects of GitHub and why it's useful in terms of like managing your own project, but then also working with other people. So hopefully you took away like some of the value of those skills. What we're going to do now is kind of transition to practicing together. And so as a group, the first thing that we're going to do is make sure that we have all the software and all the accounts put together. Okay. So I want to make sure that everyone has a Git software, which is the version control. Then you have registered a GitHub account. So you have to make sure you register an account. And then if you want to, I would recommend downloading GitHub Desktop. So I'm going to give 5 minutes. I'll kind of read the room and kind of go over the chat. Is there anyone that wants help with this right now or like doesn't have it installed at this point? If we're all good, just give me a thumbs up. Desktop.
Get on desktop. I don't have the Git version control.
Okay, Git software.
Yeah.
Go to Google and type in like download Git software, and then it'll, I don't know what kind of computer you have, but you'll need that software. This is definitely the tricky part if you've never done this before. Once you've uh, basically activated it and got it to work, you never have to do this part again. Back to sharing the PowerPoint, but just going to give people a few more minutes to just keep doing that process.
Yes, I'm pretty.
Perfect. Perfect.
And so you're saying to like make a GitHub folder on your desktop, and I would put the Git software and the Git desktop.
No, so that's a good question. So the question was about where to put the Git software if you're downloading it. I would just do the default recommended settings for where to store the downloaded software, and then the GitHub folder should just be an empty folder on your desktop. Yeah, so while everyone's doing that, why don't I pull up my desktop or my GitHub? Is this on Zoom? Is it on Zoom? Let me share. What's it? So I will kind of walk through some of the things that I've been talking about and kind of show you my GitHub while we're talking about that. Yep, 1 second. All right, so this is my personal GitHub. A lot of the stuff that we're going to be working through today is going to be coming out of this FCE workshop public repo. But this is my README file for the profile. So I just have a link to our lab, and then you can set a little like summary of who you are. You can embed links to like your ORCID ID. You can have links to any social media accounts that you use. And then, like I said, these are the organizations. One thing that I like about GitHub is that it shows you kind of your activities. So maybe if you're a person that sets goals or something, maybe you say, I want to code every Tuesday. You can have a visual way of keeping track whether or not you've made commits and whether or not you've made coding contributions. One thing that is hard to understand though is like just because you committed one thing, that could be changing a letter in the script, or it could be changing the whole script, and it doesn't really translate to how much work goes into a single commit. But that's a nifty thing that you can kind of keep track of, like when and how often you're working. If you're a PI, definitely don't use that against me. Don't do that. But let's take a look at like our organization. So this is our lab. Again, if you are not within the organization, so all of these accounts have access to it and they could see the public and private repositories. You can even divide it into teams so that certain groups have access to certain other like projects. Our private repos, you would not be able to see, but our public ones you would. And then here's a really cool one that I've been working with lately. This is part of the LTR synthesis effort. We're doing this seeker group on diversity stability, and we have a much more intensive README that we put together for this project. So we have our affiliations, we have a summary of the project, we have our motivation and our approach for finding the data. We had some key definitions of aggregate versus compositional stability, and then we're building some other resources and like our scripts, and then we even embedded like a little GIF down at the bottom, to make it just a little bit cooler. So again, one of those things that it catches people's attention for a manuscript that I'm working on or is in review right now. I have all of my public data. So this was the manuscript. We put the abstract, we put our like manuscript highlights, the keywords and stuff like that into the README itself so that anyone who's reviewing that paper or anyone who maybe found the paper and was curious about the data in it could come to this GitHub and find the exact same stuff. One thing they might be interested in, maybe they're like, oh, wow, those are really cool like plots I want to see, or maybe I want to see their supplemental biplots. All of those can be stored on GitHub and like people could pull them up and see the biplots, on GitHub itself if they wanted to. So again, these repositories kind of serve, in my mind, as individual standalone projects. And then from a scientific perspective, they're a great way to store your data, make it available, and then occasionally fill like publication requirements for like supplemental data and stuff like that. Does anyone have questions about navigating like a GitHub profile or something like that before we go on to doing stuff together? Cool. All right, let me pull Zoom back up. Right. Am I sharing screen right now? Yeah, okay. There we go. Perfect. Cool. Okay. So let's go ahead and presenter mode. Yeah. Let's go ahead and do the next task. So the first thing that I want everyone to practice is to go to my GitHub that Gabe just put in the chat for everybody. And then you're going to clone that FCE workshop repository. So the way that you're going to do that, I'll pull this up again. Okay. You'll find the repository on my GitHub, click on it, and then in that green code square, you'll click on that. And I would recommend opening it with GitHub Desktop and saving it to your GitHub folder. So I've already cloned it. I'm going to pull up that folder real quick. So this is my GitHub folder on my desktop. What's up? Oh, my bad. My bad. So here is my GitHub folder on my desktop. And if I just click on I have a folder in here called FCE Workshop, which is exactly what you're going to download or copy to your folder. And you'll see that you have pretty much everything in there. So the first step is going to be to clone that repository, clone it into your GitHub folder. Yeah, I guess what I can also do is I can delete it from my uh folder and I'll clone it again for everybody. Does that work, or were people able to do it so far? Yeah, yeah, I'll do that. Okay. So what I'm going to do, give me a second to set this up. I'm going to delete the whole repository, like delete the folder from my computer, and I'm going to download it again. Okay. Okay. So you guys can see that. Yep. Okay. So I have deleted this repository from my GitHub folder, but I'm going to clone it. So I'm going to go to this code button. We're in clone. I'm going to open with GitHub desktop. And then it can't find it because I deleted it. If I had moved it, I could relocate it, but I'm just going to hit clone again. And you'll see that it tells me where it's supposed to be. Yeah, you can't see that, can you? Right, right, right. Is there a way to, yeah, there's definitely a way to change that. Anyway, it can't find it because I deleted the folder out of my GitHub folder, but I'm just going to hit clone again. Let's see what it's doing. It's cloning that. And now if you're in GitHub desktop, you'll see that we're now in that repository. Can you see this if I pull up that folder? No, okay. But then if I go to my GitHub folder now it's back in there and we see the FCE workshop and all the material is back in the folder that was deleted. Okay. Was everyone able to clone the FC workshop repository to their computer in some folder? One more second. Okay, cool. Nice. For those of you that have done it, let's see, am I sharing the right thing? For those of you who have done it, maybe challenge yourself. Go find a public repository from a paper or maybe from an organization that you work for that has a GitHub and try and download a folder from one of their projects. Just challenge yourself to find something online. And then if anyone needs individual help, let me know.
Hey James,
Yeah.
this is John. Um, I can do all that, but for some reason I don't see it on the folder that is on my desktop.
Hmm.
Is there a reason? And I'm using GitHub desktop and I open it in GitHub browser, I open it in RStudio. I see the files, but I
Okay.
don't see them in I don't know where the folder is located that I'm
Okay.
seeing.
So did you make a GitHub folder and that was put on your desktop?
Mm-hmm.
And then the download. you can see like an R project and like an R script somewhere.
Totally. See all
But
that.
where is that?
I
In the desktop folder?
I don't see where it is at.
Hmm.
Maybe it's just on my end, but does it download it to a it should download it to my desktop, right? But that's what it does on yours.
Yeah, it might do it to your documents by default. That's another reason that like there's
Oh, hello. Yep. Thank you,
yeah,
sir.
did
That's it.
documents. Yeah,
Yeah, that was it.
yeah.
Thanks.
And the more I think GitHub gets used to it, like if you use the same folder over and over, it's gonna
It'll train
assume.
it.
Yeah,
Cool.
I think
Yep.
so.
Thanks. That was it.
Did that also maybe happen with you, Paige, where documents in the
I'm not sure. I went and tried to download one of your other ones, and then it let me try to retrace to different folders.
Oh.
And now I'm trying to add.
Okay.
See if it works.
Cool.
It
That
says, okay,
works.
now I can download it.
Cool. Perfect. Okay, I'm gonna get back to PowerPoint. Let's go there. All right. So that's probably one of the most useful things that you can do. I like to say, don't reinvent the wheel. Someone has probably done most of the analyses that you want to do. And they've probably organized it and put it on GitHub already. So if you can find those materials and know where to look, that's going to be huge for saving you a lot of time. And cloning will be big for doing that. Okay. All right. So our next step is going to be kind of practicing the push and the pull using the files that you just created. So what we're going to do now is create a new repository from scratch. We're going to call it my first repo. And then the goal is basically to create the same repository that you made with the FCE workshop material. So you're basically just going to copy that into my first repo. And then we're going to change the script and we're going to practice it. So I'm going to break that down step by step for you. But the ultimate end goal, and we'll go back to this in a second. The ultimate end goal is to do this, where we're going to change the color of a box plot. I think I actually have it different from even this right now. But the point is, we're going to first make that new repository. So let's all start with that. I'm going to stop sharing for a second, bring up the folder. So in GitHub desktop, share that. In GitHub desktop, you should see an option in the top left called File with the ability to hit New Repository. Go ahead and everyone do that, and you can call it whatever you want. I already have a My First Repo, so I'm going to call this My First Repo 2. See, it's telling me that it already exists, so I can't use it. So I'm going to call this My First Repo 2. You can choose the path. So this is where if you're making repositories and you don't want them, or you specifically do want them in your GitHub folder, this is where you get to do that. There are options to do licenses. So this is stuff that I'm not as familiar with, but if you were coding and wanted to protect the material that you're producing, whether it's data or like a software, you would have a license, and that kind of tells what people can and can't do with your products. So again, not really my area of expertise, nor really a huge issue in science, but a lot of people do the MIT license. It's kind of like the default coverall. Anyway, after you create your repository, GitHub desktop will have it set as like, this is my working space right now, we're in here. But you'll notice that if you went to your GitHub right now, like your GitHub website itself, that repository would not show up yet. You have to first publish it. So you can see here, I have the option to do it either here or this blue button right here, but I'll actually show this right now to kind of demonstrate that functionality. So I'm going to stop sharing that. Go to this. So if I look up all of my repositories right now, you guys can see that on Zoom. Yeah. There's nothing called my first repo 2. There's a my first repo, but not this one. So as soon as you publish that repository, if you wanted to put it within one of your organizations, that's where you would do it, to like your lab organization page. We're not going to do that. We're just going to publish it to my personal one. Going to hit publish. And now if I go, 1 second, give it a second to load. Now if I go in and instead look at my repositories, we should see that available. Wherever it is. Right up top. My first repo 2. So is everyone able to make their own repository? Nice. Back into this. Okay. Cool. So now that you have made your first repository, what I want you to do is just Control C, like copy and paste all of the files from FCE Workshop, that repository that you made, copy them into my first repo. And then when you're done with that, go ahead and open the R project or the practice script. I'm going to demonstrate that right now. In my folder, let's copy all of this. My first repo. Just going to paste it all in here. Okay. So now that you have copied those files over, go ahead and open up the project or open up the script. Actually, sorry, before we do that, let's actually publish this repository. So everyone should have published their repository. But now if you go to GitHub Desktop, you should see that you've made changes, right? So once you've brought those folders, those files into your folder, if you go look at GitHub Desktop now, am I sharing that? Yeah. Okay. You should see that you've made changes, right? There are 6 changes. Maybe you brought in the box plot, you brought in the script, you brought in the README, all of that should be in there. What we're going to do now is practice pushing that to the main repository. So the first thing that you have to do is write a commit message. So this thing down here in the bottom right that says summary or required, that is your commit message. Another thing that we'll talk about towards the end of this workshop is how to write a meaningful commit. But generally, you want this to be short and sweet and tell you what you did. So I'm just going to write like build and brought in all files or something. So you can add a longer description below that. You can make these commit messages quite long themselves, actually, like a full sentence, but you want them to kind of be short and sweet. If you really needed to write a description or you needed to communicate with someone, you can add that underneath as well. Then when you're ready, go ahead and hit commit to main. And you'll see that you now have an option to push the origin. So in this case, you've staged your commits, you've made changes, you've staged them, but you haven't actually modified the main repository on GitHub. So in order to do that, you're going to push the origin and send those edits basically to the living website repository server. Okay, we're going to stop. We're going to go check that that worked. So while you're practicing that, make sure you can do the same for yourself. Go to your repositories on your GitHub account, go to my first repo or whatever you called your first repository. And now you should see that those files have made it there, right? They look good. Yeah. So if you've staged, so the question there was like, stop sharing. You're saying like you made some changes, you staged them, but then you went back, you never pushed it, and you went back and like made more changes.
Yeah.
Yeah. So you can do that. As far as I know, when you send it, it'll treat it like it's one push, but it might have multiple commits that you might be able to see the differences. But I think like data wise, when you push it to GitHub, it'll save that as like one iteration of the project, I think. But it's not an issue to make multiple staged commits, I think. Is that right, Gabe?
Yeah, I usually do one.
Then do it.
I do one change, commit that, push it.
Yeah.
And then I'll make additional changes, and that way it's very clear in the chain of events.
Yeah.
Of how I updated portions. If you update your whole script, then you might, and then later on figure out something's wrong with it. Now you got to figure out exactly
Where it was.
where it was. So if you overhaul an entire script and then make that a single commit, then it might be hard to figure out where you make these errors. So if you do it piecewise, it can help in some cases if you're doing that, an overhaul.
Yep. Gabe brings up a really good point about commit early and often, make small changes and then push them so that you have a clear indication of one minor thing that was changed. But we'll talk about that in a second. Everyone was able to push material in their new repo to GitHub, right? Cool. All right. So now we're going to kind of treat it like that's a script that we're working in, and that's something that we would normally be doing and like modifying. So what you can do is in R itself, go ahead and open up that script, change the colors. If you want to mess around with it any more or any less, go ahead and just change the order of the colors and then do another commit where you're modifying the box plot and sending a new change for it. So it should look like this. So you should be able to see like a staged, hide this. At some point, a staged change, like if you run the script, again, you're gonna have to run the script once you change the colors to get the figure to change. But go ahead and run the script, change the colors, and see if you can get the modification to be pushed to GitHub.
And James, do you open the file just in the regular file explorer, or do you use the repository?
Good question. So open the file in the file explorer. So like just open up either the R project that's in your folder or the R script.
Okay, thank you.
Yep. And then again, you'll have to actually like physically run the script and it should work because it's hopefully simple. It should run. And then once it has actually like outputted the new figure, you'll be able to see the changes in GitHub desktop app. Sharing on Zoom right now, game. So this is the problem. It's good. Cool.
Is there any cap on the amount of like storage you can have sent to the server?
Yes. So that is a really good question. And most people would recommend not necessarily storing like all raw data. I do a lot with like community ecology data sets that are like thousands and thousands of rows. Totally fine. Like those CSVs push and pull normally. If you were doing something on the scale of like movement ecology and you had millions of rows, not a great place for storing data. The other thing, the other thing that people will tell you about why you might not want to store like true raw data is because GitHub can't really track like changes in a CSV file. But in my mind, you shouldn't be messing with like raw CSV files. That should all just be done in R. So, like if you were concerned about that for any reason or like wanted to check the changes of a Excel file, GitHub couldn't really keep track of them. But there are data limitations. I don't know exactly how big they are, but I want to say it's like it is something that you would run into. And the way to get around that is to store the data somewhere and then like your codes, your scripts that you run, pull the data from like a Google Drive.
Okay, yeah, that makes sense.
Yeah. But like pretty much most manuscripts are like, at least the stuff that I do, I can store the data needed for those projects on GitHub, and like it hasn't been an issue. Cool. How are we feeling on modifying our scripts, sending pushes, pulls?
I had a background problem I fixed.
Okay.
So could you just go over what exactly is supposed to change in the box call?
Whatever you want. The colors was the easy one to do.
Okay.
And so like change the colors, run the code itself, and then see if the plot was changed, right? Like the output plot should save. And then in GitHub desktop, see if that you're able to see the change and then send it to GitHub server.
Sorry about it.
No, you're good. You're good. This is one skill set that definitely gets easier and easier to do more often. Like the more you do it, the easier it gets. Really, it's just going to become second nature to you, and it's basically like saving. You know, you're pushing and pulling and just kind of like saving a document.
You have to save it first.
Yes, yeah. Yeah, essentially. Cool. Cool. All right. So now we're going to do another little exercise. I think I haven't done this one in a while, but I'm pretty sure it's pretty easy to do. So we're going to work on READMEs, and you can either do this for the repository that you just made or a new repository that you want to make, or you can do the special one where you make it for your profile. And in order to do that, I'm pretty sure you just have to make a repository that is the same as your GitHub user handle. So I'm going to stop sharing the PowerPoint. I'm going to go into GitHub itself. One second here. Okay. And so you can actually edit this directly in GitHub. So if you go to your GitHub profile, I'm pretty sure all of you can just go to the README up here and edit it like this by clicking on the little pencil icon. But you might have to make this repository first. So you'll see that this GitHub repository is called JW Sturges 1, which is the same as my handle for GitHub. And that essentially makes the README. So I can't remember if you have to make it first or if it automatically makes that when you first create your profile. But either way, this is some of the syntax that you would need to embed a hyperlink. So the brackets that you see here are what text is going to appear on like the rendered document or the rendered README, and then followed directly by parentheses with the HTML like actual web address that you want it to hyperlink to. So that's one way to do that. This is kind of a boring README in all honesty, but go ahead and spend a second making a personal README with a personal for your personal GitHub account. Yep, absolutely. So I am in my GitHub profile. I can't remember. Do you have anything up here that says README right now? Okay. Okay. Then what you're going to do is create a new repository. And you can do that in the GitHub desktop app. and you're gonna call the repository exactly what your handle, your GitHub handle is, your username. I must have one then. It's been so long since I've done this one. Yeah, here it is. Okay. So create this repository with your name. It's a public repository. And then for me, all it is the README in that. Yeah, that's what it was. Good question. So you see this pencil right here? You should be able to edit it. No, no pencil. In the other solitaire. Yes. Go to the danger zone. Let's go all the way down. Change visibility. Public. Yes. 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 See, I told you it's like it asks you 4 or 5 times before you're gonna make any change in the danger zone. Yep.
So now I go back to 1000.
Yeah, let's see if that works. Is it made? Did you make a new repository with that?
Yeah.
Yeah. There you go. While everyone is making their personal README, I'll show you probably one of the better ones that I've been a part of. This was the README for that diversity stability relationship thing that I showed you earlier. And then one thing that I like, if you are editing, you can go up here to this edit versus preview tab, and like here you're actually coding what like the actual syntax is needed, and then this gives you a preview of what that will render into when coded in HTML or whatever this is. So good little easy way to flip between the two. I think the pound symbol will decide how bold like titles are. I think if you add more, it gets bigger. I'm not entirely sure though. I guess we can check that. Yeah. If you want to embed an image into your README, this is how you would do that. You have this syntax with the less than sign, which says image, and then you have to set a file path for that. Set the width and the percentage that you want. That's what it looks like. So Hannah Marie also tells us that we're going to be spending a lot more time on READMEs and setting up stuff during her workshop. So I'm not going to spend too much more time on it. That's awesome. But yeah, very important, very useful part of GitHub is to have those READMEs, and they make your projects look a lot better. So good one to include. Yeah, yeah, I can show you that on mine. So if you want a hyperlink, the text that you're going to put to display is going to be in brackets. And then the text or the link itself is going to be directly after that in parentheses. And there, I don't think I put it in my slides, but if you look up like GitHub README syntax or something, I'm sure there's a bunch of other stuff I don't know. Anna Marie's in charge of telling everyone how to use websites and links, and this is the best I got for now. She can make it look a lot better. How's everyone's readmes coming along? They're happening? Yep. Very nice. All right. I'm gonna switch over to the PowerPoint again. But yeah, definitely mess around with the readmes. Go ahead and continue to do that as we go. All right. You guys want a few more minutes to work on readmes, or what do you guys think? You guys ready to move on?
Fun and then kind of the end.
Perfect. Okay. So we've gotten through most of the major skills that I wanted to check off for everybody today, which were being able to clone a repository that's public and then push, pull, and kind of manage a repository on your own. And for the most part, that's what most of you are going to be doing, right? Like most of your projects and most of the students at the very least are going to be kind of working on their own projects, doing their own analysis and kind of keeping their data kind of collected within their own kind of confines. But at a higher level, and certainly stuff at like the network LTR level, there's a lot of collaborative projects and a lot of things that kind of happen simultaneously. So we're going to start talking about maybe errors that you might run into if you're working with other people and multiple kind of cooks in the kitchen for the same project folder. Okay. So one of the most common things that you'll see is like a branch error where your branch is either ahead or behind the main repository. And that basically happens when multiple people are pushing and pulling to the same working directory and working repository. And either you end up with changes that you forgot to push and other people have now worked, but then your changes are now ahead, or other people have sent changes and you forgot to pull. And so you started making changes, but you didn't have the most current version. So there are several ways to avoid that in general. And I would say avoidance is your best friend. It's a lot easier than kind of resolving conflict, but there are ways to do that. And there are definitely ways to like look through the script and figure out like, okay, someone changed this. Can't overwrite the same thing essentially. However, one of the most like easy ways to completely fix this is if you have like files that you've changed, but let's say you're behind in the branch, take all of your files out, clone the repository again, and then you can put your repositories back in and like now you're back ahead, if that makes sense. but wouldn't recommend it. Instead, what I would, instead what I would recommend are these best practices. So always pull when you start working. Then you're going to want to push and pull early and often. So this is kind of up to the person and kind of dependent on how collaboratively you are working on the same script. But you can also, from a just a good practice standpoint, I would say push the work that you've done no later than like once per day, right? Like if you spend, your 9 to 5 working on code or something, I would recommend at the very least pushing that once a day. Because at the end of the day, if you lost that whole day's work, it sucks, but at least it's only one day of work. Instead of, making pushes and pulls like every hour or something. You don't need to do it that often. But it's just really don't let it go for a week or 2 weeks and then all of a sudden you have to push like a ton of data that's been changed. You'd rather have it early and often. Another thing is to write those meaningful commit messages. So as you can see here, there's ways to do that might not piss off your boss, but a meaningful commit message reflects how much work you've actually put into it. Again, why you should do it early and often. Send something that's directly related to what you've changed, and it should reflect what people see in that code. And then for collaboration, I'm currently working on a project with 7 different people, and what we have found that works best is setting separate working scripts. So if you're working in a repository and I have a script and Gabe has a script and we both make changes to it and we both push those changes, nothing goes wrong because we are both modifying different parts, like different lines in the script. But if we both were working in the same script and Gabe modified line 17 and I modified line 17, that's when you would cause an error. So for the best part, I would say, like, if you're working with multiple people, set a clear working objective and say, hey, you do that part of the analysis and I'll do that part of the analysis in my own script. Or if you are actually wanting help with like one of your scripts, send it to your postdoc or send it to your PI and say, hey, I have this issue with this script. Can you work on it? And then push it. And then when you're done with it and you've fixed it for me, tell me and send it back to me. That way I'm not working on it at the same time as you. So that hierarchy, that can be helpful for kind of never having 2 cooks in the kitchen, so to speak. Okay. And then kind of lastly, I'll touch on some resources. So GitHub has its own amazing resources that I would highly check out. I put a link to my GitHub profile page. So that's stuff like any of the analyses that I'm doing for FCE, you can check out there. We're working on putting together an entire FCE GitHub page, and we're still up in the air on what that it'll look like and like what we want it to be used for. But our idea for the long run is to definitely have students and labs contributing to it. So we want your work to live maybe on your own personal page or your lab's page, but then maybe get displayed or shared with the FCE in our own organization GitHub. And so if that's something that you're interested in working with or contributing to, let us know. And then I've also put our lab's GitHub in case your lab is interested in kind of organizing a lab repository, our lab GitHub, and kind of showing us how we organize our repositories. And then the network level LTR also has their own GitHub, which I would highly recommend for like working group projects or seeing how they do some of their data organization as well. And with that, I'll kind of answer some questions, and then we kind of have like half an hour to work and kind of maybe play around with your own projects and getting some of your own data onto GitHub. Cool. Thank you all for attending. Appreciate it. Any questions online or on Zoom or on in person? Thanks, John. Sure.
So I saw you are connected to like your lab's GitHub, and I'm pretty sure my lab has one, I think. So how do we get like into that?
Sure. So Paige's question was about lab organization GitHub and then who kind of has authority of it. So it has to be made by somebody and they will become the organizational leader. I think that there are accounts that you can pay for. I don't know how, like, if there's a difference in storage at GitHub's like organizational level, or like how much you can pay for. But essentially, like, you can make a free one and make it your organizational GitHub and then just set a hierarchy of who gets invited to it. So we can go look at that.
While you're doing that, I
Yeah.
also want to mention that initially you may want to have private repositories
Yeah.
in your lab's organizational GitHub, and so you can do that, and then later make them public as you're say getting ready to publish a manuscript or something like that. So
Yeah. Really good point there, Gabe. Definitely would recommend leaving most of your stuff private until you're done and ready for it to be public. Let's check. I think there's a way to decide. I don't know who has what access, but under the people tab, you can see who our owners are. So the owners of this include basically all of our postdocs and Rollo. So they are the people and the accounts that have access to add or remove people from the team. And I don't know, I don't exactly know how you go in and change that, but I think you just like invite people's accounts via their username.
Oh.
Yeah.
Yeah, because I also see on your homepage, you have like the FCE
Mhm.
one, so are you like, is there ways for us to join that, or you said it was kind of being built at this
Yeah.
time, so you might be one of like the builders?
Yeah, so it's by being built, I just mean we haven't added too many repositories to it yet. You're definitely like able to see it.
Mhm.
I don't think you're one of the people that could edit it yet. So I think I
Yeah, 'cause you
think
can,
I have
like,
edits to it. Yeah,
Which is what you did, so we could follow it.
you can
so we're,
follow
like,
it.
and we get updates.
Yes, and you'd be able to see the public repositories up here. So this is actually a really good plug here too. The Mike Ruge put together this awesome map figure, which I'm trying to find.
scroll down, I think
Oh, there, perfect. So yeah, Mike put together this awesome map resource, and this is a really good example. Like, I have very little experience in GIS and like making maps, and I also don't really need to reinvent the wheel for the FCE sites, right? So this is something that the script is already there, the output for it's already there, and I could go in, clone this repository, and maybe remove some of the layers I don't need, or add new layers that I want for my project. But a resource like this is what we're kind of envisioning for the FCE GitHub, where it's like students should be able to go in and download tools or scripts that will help them like not have to do this on their own. Yeah, really good resource. I love this figure too. You need what? I
believe Mike did use that in addition to an script.
Okay. In here. I see.
But I think that's the bottom. That might be the bottom.
Yeah.
I'd have to double check.
That's how he like joined the pictures. Is that what you're saying?
I think so.
Yeah.
Yeah. And he added the arrows.
Mm-hmm. Oh yeah.
But I think that top one might all be from the RC.
Yeah, I'm pretty sure at least the R's.
Yeah, it says
Yeah.
it was used.
But yeah, we're still kind of deciding what else to host here. One thought that came up was like, if your paper is published and you have a public repository exclusively for the paper, that'd be a good way to connect like public data sets, but show the application of them. Just because like a lot of our EDI data sets are maybe like even more long-term, but also kind of bare bones so that people can't use the data per se. If you wanted to have more of like, this is the subset of that data that I used for the project, it might be a good way to do it up here. But either way, those are good resources to know, good resources to contribute to, and where to find them.
Hey, James, I had a question.
Go for it.
I was curious. Okay, I don't know if this is gonna make sense, but I was curious, when do you make the decision to for a project to have a repository to organize all the data on the repository and sending it to the server versus just having your folders locally, where it could be a little bit more messy? So is it like I was thinking maybe once you're ready to start doing an analysis, that's when you would do the repository?
Yeah, pretty much. I'd say that's a good way to look at it. So as soon as I have an Excel file or like a CSV file that I want to put in R, I
Hmm.
do everything in a GitHub repository because at that point, like I'm no longer worried about losing work or like, it's saving it and tracking those changes. Um, but you're right, like obviously for the project level, there's like writing or like the papers that you have, and that kind of stuff lives on Teams for us, just because that's what my lab uses.
Okay.
Uh, but yeah, Gabe.
Yeah, so I wanted to mention, just, uh, in kind of in reference to, having like large data files, you mentioned, yeah, you don't want to like necessarily put an entirely large million row data file into GitHub. You may just want to be working with a relevant subset.
Right.
Um, and so one option is if you've published your, if you have a big data set that's published in a public repository like the Environmental Data Initiative, they will provide scripts from the website like R scripts or Python or various other types of scripts that you can pull the data into your script. So you could have that script that pulls the data from say EDI,
Right.
have that script in your repo, maybe have it output the relevant subset, so that way you've got that also in your repo.
Right.
But then that way you don't have to store a million row data set, maybe it's just 10,000 rows or whatever. And then you just have the relevant portions there that someone could copy your repo and rerun your analyses and or a collaborator, whatever the case may be.
Would that be kind of the dream for FCE then, for all data to live on EDI and then like scripts pretty much just access it directly and like
So I think it would depend if it's a small data set. There would be a lot of flexibility on where ideally you would want to have your data initially uploaded into EDI repository.
Okay.
And then you would have your GitHub repository with your analysis and your outputs, your figures and everything that's mostly associated with manuscript.
right.
And then in your manuscript, you're citing both the data sets in EDI with their own DOIs, and then you also cite what you have in your GitHub. And you can even make a DOI for what you have in your GitHub through services like Zenodo. So, and then you would have all that information in the data availability section in your paper or under references. And then so someone could go and download the full original data set from EDI, and then they could also take a look at the code and everything that you've worked with in the GitHub repository.
So yeah, just really maximizing it there then for sure, and having both available, but both manageable, I guess, in that regard.
Right.
Yeah.
And one of the things with when you upload a data set, usually the data sets don't need to be revised a whole lot unless new data are being added or something like that. But your code, as you're going through the process of working on a manuscript and publishing and then getting feedback and then having to revise, you're probably going to be revising the code and maybe the subset of the data that you're working with. So if you only have to revise the GitHub, then you don't have to go back and revise what you have in the EDI with the full data set.
Yeah. So
that
that brings up another point. And I've asked people about this, but I have gotten mixed reviews. So like as you're working on a manuscript and working in a repository, you're committing and making a bunch of changes. And then when you're at the point of publication, what a lot of people do is basically just copy their whole analysis and their whole GitHub folder or wherever they're doing it, make a new repository and just make a single one commit, one push for the like repository that they're going to cite in their paper. And so then I don't know, I don't really like that because you've kind of lost that transparency of like, here's how I got from A to B. And now here it's just like this perfect final product. So it's a little bit of both. But most people seem to do that other version where it's just saying like, here's my polished final GitHub repository, one push into a new public repo that people can see. Yeah, thanks everybody. I'm gonna stop the recording and then